Your code is worthless now. And if you understand why, you're about to make better decisions than 90% of the engineers building right now. Okay, so recently the software sector just lost $2 trillion in market cap, and that was in 1 week. And that didn't happen because the code got worse. It happened because the code got so easy to replicate. Now I'm talking about when Anthropic just recently launched an agent, as we all know now, called Cowork. I mean, it automated entire categories of white-collar work without being trained on any domain-specific data. And the market instantly repriced every SaaS company on earth. Or that's how it felt anyways. But here's the thing that really no one is covering or talking about. That repricing didn't happen because of the model. It happened because consumer hardware got good enough to run capable models locally. RTX GPUs in gaming laptops, M-series chips in MacBooks, even mobile processors. The hardware ceiling has rose. Suddenly, the workloads that used to demand cloud inference could run on someone's machine. And it's that changed everything about the economics. Now, if you know how to read that signal, you can see exactly where the value in tech actually moved. And it's not where you think. Over the last 2 years, we watched an entire category of startups get built on a simple formula. Take a foundation model API, add a prompt layer, maybe some retrieval, put a nice front end on it and call it a day, and then charge access for it. Now, the problem in retrospect is really obvious. If your entire product is a wrapper around someone else's infrastructure, you don't have a product. You basically have a feature. And the moment the platform underneath you ships that same feature natively, you're done. We saw this play out with OpenAI's plugin ecosystem. We saw it with dozens of AI writing tools that got absorbed the second the models got good enough to not need them. The pattern, though, it keeps repeating. And if anything, it's accelerating because hardware made the replication costs go to zero. For example, Claude Code runs on your machine. Cursor runs on your machine. A senior engineer with access to a capable model and local inference can rebuild your product's core functionality in a weekend. And it's not because the engineer is 10 times better. It's because the hardware is available and the model is accessible. And let's take a step back here. That is not a criticism of engineers or any of these engineers. It's really about the fact that it's a signal about what's happened to the moat. Now, the companies and the engineers who are building durable positions right now aren't the ones shipping the most features the fastest. They are the ones who understand that the application layer got commoditized the moment inference became local and cheap. So it brings up the question, where did the value move? It moved down to the layer underneath. A team starts building, they pick a database for their core application data, users, sessions, transactions, whatever the domain requires. It works, and then they ship it. 6 months in, they need search. Now, I'm not talking just basic queries, actual full text search with relevant scoring, fuzzy matching, autocomplete. That used to mean spinning up Elasticsearch or Algolia or any other service really. Doing things such as sync pipelines, having another set of credentials to manage. The list goes on. Then AI features show up. Vector search for semantic retrieval, or maybe a recommendation engine, maybe RAG support for a chatbot. That's potentially a third system, something purpose-built for embeddings. Now, each of these tools might be fine on its own. The cost, though, is in the seams between them, in the things between them, the data duplication. The eventual consistency gaps, and as we all know, the operational complexity. So this is where I found that MongoDB is a great example. MongoDB Atlas. It gets really interesting because they made a deliberate architectural choice that most database companies didn't. Instead of being good at one thing and forcing you to bring in other vendors for everything else, they built a platform that keeps expanding underneath of you. For example, when you define an Atlas search index, you're still querying the documents in the same cluster. What that means really is you are not having to sync to pipelines, no second vendors. When vector search showed up on everyone's roadmap, do you remember this? Atlas Vector Search landed on that same foundation. And then they integrated Voyage AI's embedding models directly into the platform, which is currently in public preview. So basically you define an auto embed field in your vector search index, and the database generates embeddings on write using the Voyage 4 models, which outperform, by the way, both Gemini and Cohere on the RTEV benchmark, which is pretty incredible. So no external embedding services. There's no separate embedding pipeline to build or manage. That's 3 layers of capability on one platform, added really incrementally without re-architecting it. That's really what happens, or what compounding infrastructure actually looks like. You're not starting over each time your requirements grow. Instead, you're building on decisions that keep paying forward. Now, I want to zoom back out for a sec here because that same principle operates at massive scales. And this is where you can see the hardware thesis really exposed. The companies with the strongest competitive positions right now aren't the ones with the best model. Stay with me here. They are the ones who locked down the physical layer. Some examples of this: Microsoft just signed a 20-year agreement to restart 3 Mile Island nuclear plant, which is, by the way, 835 megawatts of power. Amazon bought a data center campus near to a nuclear facility in Pennsylvania for $650 million. Google signed power purchase agreements for small modular reactors. These aren't just coincidence or marketing stunts. These are companies securing engineering capacity years before they need it. They are looking ahead because they know too the bottleneck is coming. And when you think about this, it's a big one. LLM inference at scale draws 10 to 100 times the compute of a web search. When you're running inference for millions of users all at once, the power grid becomes your constraint, not your model quality. Now, I'm sure many of you throughout this video are thinking, what about NVIDIA? Well, NVIDIA's position is pretty interesting too. Their moat was never just their GPU hardware. It was CUDA, in my opinion. A decade of developer tooling, libraries, optimization work. I mean, all the infrastructure that made switching away from NVIDIA a very painful experience, even when the silicon alternatives showed up. For example, Google's TPUs, Amazon Trainium, Apple even with their neural engines. The chips exist, but the software ecosystem around NVIDIA kept pulling people back, and still does. But now you're really seeing the next version of this play out in real time. I mean, custom ASICs are on the rise because companies running inference at scale realize that renting NVIDIA's margin structure forever is a bad strategy. Apple designs its own silicon. Amazon designs Graviton for general compute and Trainium for AI workloads. I mean, NVIDIA itself is now shipping NemoClaw, which is, as we all know, an enterprise agent platform that runs on local hardware with policy-based security control. They're not waiting for OpenAI or Google to own the agent layer. They decided to build it themselves. And I think this is really key because you can start seeing the pattern is the same every time. If a layer of infrastructure is critical to your business, eventually you have to own it. And when every major tech company starts making the same investment at the same time, to me, that's not a feature race. It's a signal about the next era of computing that is getting built. Okay, so here's where the thesis inverts get a little bit uncomfortable, if you will. A study measured actual developer velocity with AI coding tools. Now, this wasn't self-reported, this was measured. So developers believed they were 20% faster. They were actually 19%, get this, slower. A nearly 40-point gap between perception and reality. Meanwhile, 90% of Claude Code's commits land in repository with fewer than 2 stars. I mean, that's personal experimentation. It's throwaway code. The application layer just got mass-produced, and most of what's being mass-produced is just mess or noise, if you will. But the commercial side tells a different story. Anthropic's Claude Code went from $0 to $2.5 billion in annualized revenue in 9 months. 8 of the top 10 companies by revenue now use Claude Code. Enterprise accounts represent more than half the revenue. So there's a huge split happening. I mean, on one side, you have massive amounts of generated code that doesn't matter, if we're being honest here. And on the other side, you have enterprises paying premium prices for infrastructure that lets them deploy AI at scale. Now, the inversion that I spoke about earlier is exactly this. The engineers winning right now aren't the ones writing the most code. They are the ones who understand what's underneath the code. They understand why things like local inference matter, when the cloud inference actually makes sense to use instead. They understand why choosing the right data infrastructure compounds, that the application layer is now cheap, so the value lives in the layer beneath it. The people who treat infrastructure decisions as an afterthought end up rebuilding 6 months later, but the people who think carefully about the foundation keep shipping on top of it. And I want to go back to MongoDB about this because this is another example as to where they keep showing up, not once again as a feature, but as a proof of the thesis I'm talking about here. So when MongoDB shipped their MCP server, that wasn't a product add-on. That was saying, we understand your infrastructure needs to meet you where you're already working. You're using Claude Code, Cursor, Copilot, whatever. Your coding agent needs context. Your database can provide that context directly through a standardized protocol instead of forcing you to switch tools. Now, to go further with this, the MCP server reads your schemas, samples documents, integrates performance advisors. Your agent can identify slow queries and recommend indexes, all without leaving your IDE. I mean, you can even spin up local dev clusters via Docker, so you're not burning managed infrastructure during development. That is infrastructure thinking. It's not feature thinking. The database understands that it's a component in a larger system now, and it's building tooling that compounds with the tools around it. And Atlas, which we spoke about earlier, itself has become genuinely deep as a platform. I mean, you have things such as your operational data, search layer via Atlas Search, vector capabilities, stream processing, so many things under one roof. And I mean, not to mention a free tier that lets you start building all without a credit card. Now, when your hardware and your data costs are low, you can afford to let people experiment. The AI wave made a lot of people think about the application layer and that it is where the value lives. Ship a feature, grow fast, figure out the rest later. And for some products, that's still true for about 6 months. But the companies and the engineers building the most durable positions right now are the ones thinking about one layer deeper. They're asking whether they actually own the thing their product depends on, or whether they're renting it from someone who could take it away from them. That question still applies whether you're a hyperscaler buying a power plant or a 3-person startup choosing a database. The scale is different, yes, of course, but the principle, in my opinion, is the same. Now, hardware got cheap, code got cheap, so the moat moved down to the layers that don't get replaced. That is where infrastructure compounds. So really, make sure you choose accordingly. Now, if you want to see what that looks like in practice, MongoDB Atlas is a really good place to start. So I linked it down in the description. But I'm curious, do you agree with me on this topic? I really want to have some discussions in the comments, so leave down your thoughts down below. I'm so happy when people agree with me, but equally, if not more happy, when people push back and have other thoughts and opinions. So let's get to it. I'll see you in the next video.